Good morning, everyone. Hope you guys are still doing well, not going too stir crazy. So today we're going to talk about elimination one more time for systems of equations. I'd like to introduce you to my office assistant for today. This is Simon, and he is a Siamese cat, I think. I don't know, but Simon's going to help keep me on track here. So where we've been is that so far you've had systems of equations that have had common coefficients where we could either add or subtract to eliminate. So here we would subtract the x's because x minus x is 0. Here we would subtract the y's because y minus y is 0. Trying to see here on number 6, which I worked out last night with one of your classmates. So that's why I've got writing on my paper. But here on number 6, we added them. And so what the tip that I came up with for the person that I was working this out with is I said, you know, if you look at the common coefficients, here I've got 3's in front of the y's, but one is a positive and one is a negative. So if they're opposites, we're going to use addition because that will cancel them out. If they're exactly the same, like here on number 8, we're going to subtract them because 6 minus 6 is 0, and they'll cancel each other out. So I hope that kind of makes sense. So let's talk about what happens if we don't have common coefficients. If I look at number 1 here on my example, even if I subtract these, the x's are not going to cancel out. Even if I add them, those x's won't cancel out. And same story for the y's. So what if there are no common coefficients? Well, if you remember me telling you that you can do anything you want to an equation as long as you do it to both sides and to every term in the equation, that's the idea we're going to use here. So if there are no common coefficients, we're going to multiply. Don't worry about division. We're going to multiply one or both of the equations by some number. It can be whatever we come up with as long as we multiply both sides and every term. We're going to multiply one or both of the equations, like I said, by some number you get to pick, or you will determine that. So that we then have common coefficients. The nice thing about this also is that if your favorite thing is to add the equations, then you can pick so that you get opposite signs. We can pretty much never have to subtract again. Or if subtraction is your favorite, you can never have to add again. So let's take a look at example number 1. Here, if I only had a 2 in front of that x, I would have 2 x's here, right? Or if I only had, and you'll be thinking about common denominators. You know, what's the least common multiple of 3 and 7? So, but the easiest thing to do here is going to say, wait a minute, if I just multiplied that x by 2, I'd have 2x and 2x. So what we're going to do is we're going to take this equation. Remember I told you that if you want to get opposite signs, so if I multiply this whole equation by -2, watch what happens. I'm going to multiply the entire thing. X plus 3y equals 6. Okay, so this looks a little different than how I usually write it. But we're just saying we're going to multiply this entire equation by -2. Well, what that's going to give me is -2 times x, -2x, -2 times 3y is -6y, and -2 times 6 is -12. Okay? Now let's bring down this other equation. And so we have transformed one equation. We're going to leave the other equation the way it is because everything is going to work out. So now, what happens if I add negative 2 plus 2? Those cancel each other out. I could have multiplied just by 2 and then subtracted, but I prefer addition. It makes a little more sense to me. It helps me keep things straight. And I've told you guys before, those little negative signs, they can be disastrous if you lose them or forget them or misplace them. So I just kind of like to have opposite coefficients here. So now, what happens if I add negative 2 plus 2? Well, that's 0x. Those have canceled each other out. Now we're going to add negative 6 and negative 7y. That gives me negative 13y's. And likewise over here, if I add negative 12 and a negative 1, it's negative 13. So what does y equal here? Well, if I divide both sides by negative 13, I will get that y is equal to 1. Now you guys know what to do. Once you get one of your coordinates, you got to go get the other one. So we're going to take y equals 1. We're going to plug it into one of these two equations. Doesn't matter which one. I always pick the simpler equation, so I'm going to plug it into x plus 3 times y. Y is 1 is equal to 6. That tells me that x plus 3 is equal to 6. So can you tell me what x is equal to? Yep, x is equal to 3. So that tells me that the coordinates of the intersection of these two linear equations here, the coordinates are x is equal to 3, y is equal to 1. Okay? I'm going to do 2 more examples, but I'm going to have to put them on different videos because one valuable lesson I learned yesterday is that if the videos are longer than about 7 minutes, they don't want to upload so easily. So we'll take a little break here, and I'll be back in just a minute.